Have you ever looked up at the night sky, all those stars, and wondered, is anyone else out there looking back at us?
It's a question that's captivated humanity for millennia.
And today we're going on a deep dive into one of the most famous attempts to tackle that question.
The Drake equation.
Now, before we get too far, I think it's important to clarify that the Drake equation isn't really about getting a precise answer.
Right. It's more like a thought experiment, a way to frame the question of life beyond Earth in a structured way.
So it's not like plugging numbers into a calculator and boom, out pops the number of alien civilizations.
Not quite.
But it does give us a way to think about the different factors that would influence the possibility of intelligent life existing elsewhere in the Milky Way galaxy.
Exactly. It helps us break down this incredibly complex question into smaller, more manageable pieces.
So kind of like a cosmic recipe where each ingredient represents a crucial factor.
I like that. A cosmic recipe for alien civilizations.
So let's start with the first ingredient on our list,
All right, that would be R star.
our star.
It stands for the rate of star formation in our galaxy. Essentially, how many new stars are being born each year.
Okay, so more stars, more potential solar systems, more chances for life to emerge. Seems pretty straightforward so far.
It does, but here's where things get interesting. Astronomers estimate that only 1 to 3 new stars are born in the Milky Way each year.
That doesn't seem like a lot.
It's not a lot when you consider the vastness of our galaxy. But remember, our galaxy is billions of years old.
Oh, right. So even a slow rate over that immense timescale.
It adds up. We're talking about hundreds of billions of stars in the Milky Way.
Wow, it's hard to even wrap your head around a number that big. Each one of those stars, a potential sun for planets.
And potentially for life.
It really makes our little solar system feel pretty insignificant, doesn't it?
It certainly puts things into perspective.
So we've got all these stars, but obviously not every star is going to have planets orbiting it right.
True. And that brings us to the next ingredient in our cosmic recipe, FP, the fraction of stars that actually have planets.
And this is where things get really exciting because we've learned so much about exoplanets in recent years thanks to incredible telescopes like Kepler.
Absolutely. In fact, recent discoveries suggest that planets might be even more common than we initially thought.
Really?
It seems that almost every star out there likely has at least one planet.
Wow. So we're not just talking about a few planets sprinkled here and there.
Nope, we're talking about a galaxy teeming with planets.
It's like finding out your quiet little neighborhood is actually the heart of a bustling metropolis.
I love that analogy. And this abundance of planets has huge implications for the potential for life.
But of course, just having a planet isn't enough, is it? It needs to be in the right place for life to take hold.
Exactly. That brings us to the number of planets in what we call the habitable zone.
Right, the habitable zone or the Goldilocks zone, as it's sometimes called.
Not too hot, not too cold, just the right conditions for liquid water.
And liquid water, as we know it, is considered essential for life.
Absolutely.
So where does our solar system fit into all of this?
Well, Earth, of course, sits comfortably in our sun's habitable zone,
Yeah.
which is a big part of why we're here.
Makes sense.
But what's interesting is that our neighbors, Mars and Venus, they fall just outside of this sweet spot.
So Venus is too hot, Mars is too cold.
Exactly. Venus is a scorching inferno, while Mars is a frozen desert.
A delicate balance.
Very delicate.
So how many planets across the entire galaxy could potentially be in this habitable zone?
Based on current estimates, it could be billions.
Billions.
Billions of planets with the potential for oceans, for rain, for rivers, and maybe even for life.
It's mind-boggling.
Uh,
But even if a planet is in the perfect spot, even if it's in the Goldilocks zone, that doesn't automatically mean life will just spring up right.
You've hit on one of the most fundamental mysteries in this whole equation, like the fraction of habitable planets where life actually emerges.
And this is where our Earth-centric perspective really limits our understanding, doesn't it?
It does, because right now we only have one data point, our own planet.
We know life arose on Earth,
And remarkably early in its history, which gives some scientists hope.
that it's not some incredibly rare fluke.
Exactly. That maybe life is a natural consequence given the right ingredients.
Like that saying, life finds a way.
Exactly. But until we find life, even microbial life, on another planet, it remains a huge unknown.
It makes you wonder what the discovery of even the simplest life form on another world what that would do to our understanding of this whole equation.
Oh, it would be revolutionary. I mean, finding even a single-celled organism on another planet would rewrite our understanding of life's place in the universe.
We wouldn't be alone, at least in the most basic sense.
Exactly. And it would increase the probability of more complex life existing elsewhere.
So let's say, for argument's sake, that life does exist on other planets. What are the chances that it evolves into something intelligent?
Now we're getting into the realm of intelligence, and that's what the next term in the Drake equation addresses, phi. It stands for the fraction of planets with life where intelligent life actually evolves.
So we're talking about beings that can think, communicate, maybe even build spaceships.
Potentially even beings that could be looking up at the stars and asking the same questions we're asking right now.
It's amazing to think about.
It is, but it also raises a lot of questions. Because remember, on Earth, it took billions of years for intelligent life as we define it to emerge.
So is intelligence a rare outcome?
That's a question scientists are still grappling with. Is it a fluke, or is it a more common development given enough time and the right conditions?
It's fascinating to think that even if it's a long shot with billions of potentially habitable planets out there, there's still a chance, right?
Absolutely. The sheer scale of the universe means that even improbable events could still occur multiple times.
So even if intelligence is a 1 in a million chance,
With billions of planets, that 1 in a million chance could still result in countless intelligent civilizations.
so, okay, let's say there are other intelligent beings out there somewhere in the vastness of space. How do we
Right.
find them?
Well, that's the next challenge, and it's reflected in a fraction of civilizations that develop technology detectable to us.
Detectable to us. So it's not enough for them to be intelligent. They have to be using technology that we can pick up on,
Precisely. Think about it. We've been sending out radio waves for about a century.
which on a cosmic timescale is nothing.
Exactly. A mere blip. But what if other civilizations are using technology we haven't even dreamt of yet? Technology that's beyond our current understanding.
It's like trying to find a needle in a haystack, but we don't even know what the needle looks like.
It's a real possibility. Our own technology is changing so rapidly. Who knows what we'll be using to communicate in 100 years, let alone 1,000 or 1,000,000.
Maybe we're looking for the wrong signs, listening on the wrong frequencies.
Maybe. Or maybe our instruments aren't sensitive enough to pick up the whispers of another civilization across the vast cosmic distances.
It's a daunting task. And even if we did manage to detect a signal, wouldn't there be another hurdle? Civilizations rise and fall. They change, they evolve.
You're thinking about L, the length of time a civilization is able to communicate.
Right. What if our window of technological overlap with another civilization is just misaligned?
It's possible. We might only have a very narrow window of opportunity to detect another civilization, and they might face the same limitations on their end.
Imagine civilizations rising and falling, their signals fading into the background noise of the universe without ever crossing paths.
It's a sobering thought, like ships passing in the night in a vast and very dark ocean.
So all of this leads us back to the big question, the one that's kept us staring up at the stars for millennia. Are we alone? Does this equation, this grand cosmic recipe, ultimately give us an answer?
Well, not exactly. As we've discussed, the Drake equation isn't about finding a precise number.
It's more about understanding the vastness of the problem.
Exactly. It helps us appreciate the incredible complexity of this question, the vast possibilities that exist out there, and the sheer scale of the universe we're trying to understand.
It's about the journey of exploration, the process of asking these questions, more than arriving at a definitive answer.
I think that's a great way to put it. The Drake equation encourages us to keep searching, to keep exploring, and to never stop wondering about our place in this vast, awe-inspiring universe.
Even if we never find definitive proof of another civilization.
The very act of searching, of questioning, tells us so much about ourselves and our place in the cosmos.
So it's more about the search than the finding.
In a way, yes. It's about pushing the boundaries of human knowledge and understanding. And who knows, maybe someday the Drake equation won't just be a thought experiment.
But a roadmap.
Maybe. A roadmap to a future where we're no longer alone, but part of a vast, interconnected web of life and intelligence.
It's a truly awe-inspiring thought, but it also raises another even bigger question. What would the discovery of another civilization actually mean for humanity? How would it change us? How would it change everything?
It really makes you think, what if they're out there, on some distant planet looking up at their night sky, asking the same questions we are?
And using some version of the Drake equation to try and figure it all out.
Exactly.
So when we look at this equation, this cosmic recipe, what kind of answers does it actually give us?
Well, it's not really about finding a single definitive answer.
More like a range of possibilities.
Exactly. It's more like a spectrum.
So are we talking about dozens of civilizations out there? Hundreds, millions?
Well, that's where the real debate begins.
Give us a sense of the scale we're dealing with here.
Well, the results you get from the Drake equation, they depend heavily on the values you plug in for each factor.
Right, and as we've been discussing, there's a lot of uncertainty around many of those values.
A lot of unknowns.
So depending on how optimistic you are.
Some researchers taking a more optimistic view have estimated that there could be thousands or even millions of civilizations out there right now.
Millions?
Yeah.
Wow, that's just incredible to think about.
It's mind-boggling, the diversity of cultures, technologies, ways of thinking that could exist out there.
It's almost too much to comprehend.
It really stretches the imagination, but of course, as with all things scientific, we need to balance that sense of wonder with a bit of caution.
Right, not everyone agrees with those optimistic estimates.
Exactly. Other scientists, taking a more conservative approach, they arrive at far fewer potential civilizations.
Like how many are we talking?
Maybe just a handful scattered throughout our galaxy.
Or maybe, and this is kind of a scary thought, maybe we're totally alone.
It's a possibility, however improbable it may seem, given the vastness of space it could be, that the conditions for intelligent life to arise and then to thrive long enough to be detectable are incredibly rare.
So on the one hand, we have this huge universe, billions upon billions of stars and planets.
And on the other hand, the possibility that we might be the only ones looking up and asking these questions.
It's almost a paradox, isn't it?
It is, and it's precisely why the Drake equation, even with all its uncertainties, is so valuable.
It's not about finding a specific number.
It's about helping us understand the vastness of what we don't know.
To consider the full spectrum of possibilities, from a galaxy teeming with life to the potential of our own solitude.
Exactly.
So I'm starting to see that the real power of the Drake equation isn't in the answers it gives us.
But in the questions it forces us to ask.
It's a call to keep searching, isn't it? To keep exploring.
Absolutely. It's a reminder that exploration, both physical and intellectual, is at the heart of what makes us human.
Pushing the boundaries of our knowledge and our understanding.
Precisely.
It makes you wonder if those hypothetical civilizations out there, are they also looking up at their night sky?
Pondering the same question.
Maybe even grappling with their own versions of the Drake equation.
It's a very unifying thought.
To imagine other beings, perhaps vastly different from us, sharing that same spark of curiosity, that same yearning to understand the cosmos.
It speaks to something fundamental about our shared existence, doesn't it?
This desire to connect, to find meaning, to know that we're not alone in this vast universe.
It's a powerful drive.
All this talk about searching for other intelligent life, it brings up a pretty big question, one that's always kind of fascinated me and maybe even scared me a little bit.
What is it?
What if we actually did receive a signal, a clear, undeniable message from another civilization?
Wow, that's the ultimate question. Isn't it a question that's fueled countless science fiction stories, philosophical debates, late-night conversations? Probably since humans first looked up at the stars.
It's a scenario that could change everything. Literally rewrite our understanding of everything.
It would be a paradigm shift, unlike anything we've ever experienced.
Just think about the impact.
On religion, on science, on our social structures, on everything.
It's exhilarating and terrifying all at the same time.
You've hit the nail on the head. The confirmation of extraterrestrial intelligence would be a revolution.
I think there would be a lot of fear,
Of course, the unknown can be unsettling.
but also maybe a sense of unity. You know, facing something so much bigger than ourselves might just bring us all together.
Yeah. It's certainly possible shared threats, or in this case, shared awe, have a way of transcending our differences.
But let's be realistic, there would probably also be chaos.
Oh, absolutely.
And we think about the potential for conflict, economic upheaval, political instability, even religious turmoil.
It would be a challenge unlike any we've ever faced.
So how do we even begin to prepare for something like that?
Well, that's why it's so important to start thinking about these questions now, to have these conversations before we're faced with the reality of contact.
So we need to be proactive.
We need to think critically about the potential consequences, both positive and negative, of contact with another civilization. We need to develop ethical frameworks, communication strategies, plans for how we as a species would respond to such an event.
It's almost like preparing for a guest whose customs and language we don't understand.
Exactly.
Yeah.
We want to be welcoming, but also cautious, respectful, but prepared.
Because the way we handle first contact could have implications not just for humanity, but for the future of both civilizations.
That's a huge responsibility.
This is so much bigger than just science, isn't it?
Absolutely. It's about philosophy, ethics, the very nature of our existence.
The search for extraterrestrial intelligence, it's a journey that takes us to the heart of what it means to be human.
It forces us to confront the big questions, to grapple with uncertainty, and to embrace the unknown.
And even if we never find definitive proof that we're not alone, even if the Drake equation remains just a thought experiment, the very act of asking these questions, of searching and exploring it, tells us something really profound about ourselves.
I agree. It tells us that we are a species driven by curiosity, by a thirst for knowledge, and by a deep-seated yearning to understand our place in this vast tapestry of the cosmos.
It's a journey worth taking regardless of the destination.
Absolutely.
It's like we've been exploring this vast cosmic ocean, and we're just starting to realize how deep it really goes.
And how much we still don't know.
The Drake equation is like our first little boat, helping us navigate these uncharted waters.
A framework for our exploration.
And even if we never find that definitive proof that we're not alone, even if we never encounter another intelligent civilization,
The journey itself is already changing us.
reshaping our understanding of who we are and where we fit in.
It's a reminder that exploration, both physical and intellectual, it's at the very core of what makes us human.
It's what drove us to explore our own planet,
To cross oceans, to climb mountains.
and eventually to reach for the stars,
And now it's driving us to look even further, to peer deeper into the universe.
seeking answers to questions that we may never fully grasp.
It's the ultimate expression of human curiosity.
I've heard some people say that this whole search for extraterrestrial intelligence is a waste of time and resources.
That we should be focusing on problems here on Earth.
What would you say to that?
Well, I understand that perspective. Of course, we have a lot of challenges here at home, but I think the search for life beyond Earth, it's not a distraction from those challenges.
It's part of the same drive that pushes us to solve those problems.
Exactly. It's about pushing the boundaries of our knowledge and our understanding, and in doing so, we often discover things that have practical applications here on Earth.
New technologies, new ways of thinking.
Even new perspectives on our own problems.
It's like by looking outward, by trying to understand the vastness beyond our planet, we end up learning more about ourselves.
We gain a new appreciation for our own planet and for the fragility of life.
It's pretty amazing, isn't it?
It is. It speaks to the interconnectedness of everything.
This whole conversation has been quite a journey.
We've covered a lot of ground.
We've delved into the mind-boggling possibilities of the Drake equation, grappled with the profound implications of contact, and really explored the very nature of human curiosity and our place in the cosmos.
It's been a pleasure.
And to our listeners out there, I hope this deep dive has ignited your own sense of wonder.
And inspired you to keep asking those big questions.
Because even if we never find that definitive proof that we're not alone, the search itself is a testament to something truly remarkable about humanity.
Our endless curiosity.
Our drive to explore, to question, to reach for the stars.
And who knows, maybe someday in the not-too-distant future, we'll look back at this conversation
At the Drake equation.
and see it not just as a thought experiment.
But as the first step on a journey that led us to a much deeper understanding of our place in the universe.
In a vast, interconnected web of life.
A universe teeming with possibilities, just waiting to be discovered. Thanks for joining us on this deep dive. Keep looking up and keep asking those big questions, because you never know what incredible discoveries await just beyond the horizon.